So yeah, today I want to introduce RisingWave version 2.7. And version for RisingWave 2.7, it was released in December 2025, and it was the last release of the 2025. And for version 2.7, we focused on three topics: the deeper Iceberg integration, the faster backfills, and the stronger security and ops. So yeah, as usual, I just want to do a very quick introduction about myself. I'm the founder of RisingWave, and yeah, that's it. So for RisingWave, yeah, I believe that's what everyone here knows what RisingWave is, and definitely RisingWave is nowadays one of the most popular stream processing system in the world, and we're pretty much focused on enterprise grade for real-time ingestion, stream processing, and Iceberg maintenance. So for the upstream systems where the data could come from, originally that we are pretty much focused on these three things. For the let's say the Kafka, let's say Postgres CDC, and the data lakes and warehouses. But well, if you have already used RisingWave, you probably noticed that okay, we actually can ingest data from all different sources, all various kinds of the data sources like Pulsar, like Red Panda, like MongoDB CDC, like MySQL CDC, Azure CDC, right, and many other destinations. And for stream processing, definitely RunWave is the leading player, in the domain. Um, for Iceberg, we have already been keeping building Iceberg integrations actually we started building Iceberg integration around 3 years ago, and we pretty much focused on productionize the Iceberg integration since 2025. And over the last 1 year, we definitely made a lot of achievements on the Iceberg maintenance. And I will also cover that for later and about to discuss more about what you can do with the with RisingWave's Iceberg integration. So yeah, today's topic is about version 2.7, right? And essentially, I just want to give you an overview about our release. The first release of RisingWave, public release of RisingWave was version 0 point 0.1, and it was released in April 2022. And that was, yeah, almost 4 years ago. Yeah, time flies, right? And over the last 4 years, well, we delivered to yeah, version 1.0. Sorry, yeah, 1.0 in July 2023, and 1.2 on October 2024, and now we're at 2.7. And the key thing I'm pushing for 2026 is to deliver the version 3.0, and it will be a major milestone for RisingWave because right, it probably means a lot of things. Like okay, we have a really good integration with features for the real time ingestion, real time stream processing, and very solid for the integrations with Iceberg. And for 3.0, we probably will focus on something like okay, wider connectivity with upstream services, as well as the something like okay workload isolation. We have already had that, but what a more dynamic workload isolation, as well as probably something regarding AI. Yeah, I will cover that later. So for version 2.7, we have definitely have a stronger Iceberg integration, backfill performance, operate optimizations, and for security and operations, we have the LDAP authentication. Yeah. So when we talk to customers, we feel that definitely, I know that many of the customers come to RisingWave because of the stream processing capability, right? And well, and main, and they many of our users and the customers used to sync the data into, let's say, different data warehouses like Snowflake, like Redshift, yeah, probably some other destinations. But one key trend we find over the last 1 year is that everyone tries to sync the data into Iceberg. That's definitely a major trend. We didn't really notice that in on 2024, but over the last 1 year, everyone just want to sync the data directly into Iceberg because they feel that okay, it's the open data format and they can use any query engine to query the data from there, right? So we acknowledge that when we definitely believe that's what Iceberg is feature. And for point seven, version point seven, we spent a huge amount of time in improving the integration with Iceberg. And for backfilling, one of the key challenges for in stream processing system is that okay, backfilling the data from upstream services or even just review the material view, right? Well, review the let's say so-called streaming job can take pretty long time. And this was because because when you try to backfill data, yeah, when you try to create a material view, the first step is not about okay, just directly ingest the streaming data, but to backfill from the upstream services, right? Well, or backfill from upstream tables. Imagine that if you have, let's say, have a large table of, let's say, 1 TB of data, it could probably spend a huge amount of time in backfilling. So we work with some yeah financial guys and they have the data like probably 10, 20 TB and it probably can take hours to backfill the data. So we believe that backfilling is definitely one of the key pain points in the stream processing systems, and that's why we also spend a huge amount of time in improving the experience. And nowadays, well, if you use RisingWave, you will feel that well, you probably will um, um, get probably the best backfill performance well compared to any other systems any other streaming systems in the world. And for LDAP, I have to say that well, it's definitely for enterprise customers, right? And I'll also cover that later. So let's talk about for the Iceberg integration first. For Iceberg integration, before 2.7 version 2.7, we have already you can already ingest the data directly from the Iceberg and also let's say write the data into Iceberg tables. But we didn't really have before 3.7 was vendor credentials and yeah, we didn't really have that well before 1.7. In the meanwhile, we also didn't really have very advanced compaction strategies, and I'll also cover that well in today's well in later. And in 2.7, we also supported refreshable tables in our which means that okay, even if your Iceberg table if you want to ingest data directly from Iceberg tables, even if you update or delete data in Iceberg, we could also ingest data directly from there. So I will cover that. Okay, let's first discuss about banded credentials. So for vendor discussions, if you're not familiar with what this topic, well, I have to say that well, this definitely not specific to vendor discussion itself is not specific to Iceberg, but for a modern Iceberg solutions, well, definitely you heard that well, people are promoting about well vendor credentials, and I have to say that well vendor credential is one of the key building blocks that's a part that ensures that you can adopt Iceberg in enterprise environments. Why? Imagine that, okay, if you do not really vendor the credentials, what do we like? So Iceberg is the basically the open table format, right? And it has the catalog service. And for catalog service, it could be like a Polaris, right? Or Apache Polaris, or probably the Unity catalog or Lake Keeper or something else, right? And the pain point here that well, if without vended credentials, then basically what it look like is that there are systems, for example, RisingWave, right? Or for example, the Snowflake, or for example, Spark, right? Will talk to the Iceberg catalog and get a permission, right? Well, it will authenticate, right? So, okay, when I do have the permission to access the data, it will talk to a catalog and get a key and use the key to access the data in your S3 table, right? That's the process. But the pain point here is that look. So imagine that in your organization you have let's say 10 different data engineers or probably 100 people in the organization. And some of them probably just want to temporarily access the data, right? Or you probably also want to share the data outside the organization, right? In that case, you probably don't really want to share your keys with them, right? So because well, it's kind of like risky. For example, what if let's say they share the key with some other guys and you will not know that, right? Well, definitely that's pretty risky. But with vendor credential is a very nice solution that can help you to address the problem. How it works? It works like okay, if you talk to the so you can you if you talk to a catalog, the catalog service will just issue a short-lived temporary credentials so that with the short-lived just-in-time token, you can access the cloud storage. You can use the token to get access to the storage. And for this access, you will not know the detailed S3 address. So that's okay. You can safely, but well, you can still access that. So this in this strategy, well, I mean, in this way, you can definitely have a very secured access to the to your data to your raw data, right? And I mean, so for the for using this strategy, I mean, I have to tell you that well, okay, for the credentials will be refreshed right every I don't know. Well, I mean, it will be refreshed automatically. Like I don't know how long it will the frequency of the yeah refreshness. Well, but well, I mean, you can check your catalog services. But well, I mean, as long as your catalog service supports a vendor credential, RisingWave can talk to the vendor catalog service and to refresh them automatically. So that's where you can safely share your keys with your let's say teammates, with your let's say with your I mean yeah with your I mean so, with some other guys who are probably outside of organization, right? Without worrying about well yeah leaking the secrets. So how to use this feature? I mean, I have to say that okay, it's pretty simple to use that as well. I mean, whenever you create you connect with the catalog, you can just use this parameter called vendor credentials and set these parameters to true, and you can enable the vendor credential strategy. So that's pretty simple, right? Yeah. And then let's talk about the compaction. I have to say that's what I mean. The key problem with the iceberg is that well, how you handle compaction, right? And essentially in RisingWave, we support well not in the past we support why we need to have compaction because whenever you write the data into Iceberg, you can probably create a lot of like small files, right? Because well, okay, let's say that's where you ingest the let's say a Postgres CDC from Postgres to Iceberg, and let's say you commit every single minute, right? For every single minute, you can probably generate a small files right in Iceberg. And if you have a lot of small files, then you will find that okay, the iceberg in which I mean you have to and then you will find that well, if you want to query the iceberg table, it will have to access so many small files, right? In this way, I mean it could be very slow. So we definitely want to do compaction, right? Um, yeah, yeah. So yeah, you definitely want to do compaction, right? So regarding the so for RisingWave before 2.7 we supported full compaction, which means that okay. So imagine which means that okay the compaction service the background compaction service will periodically compact the full table um, yeah, yeah, in a full table frequently. For example, if your table is, let's say, 100 gigabytes, right? And we will compact these 100 gigabyte tables every, let's say, 15 minutes or every single minute, right? So that's how we did well before 2.7. The strategy is great, right? And I mean, it's very standard strategy, and I believe that okay, everyone use that strategy. A lot of people use that strategy, and it's very standard maintenance. It basically merges the data files to optimize the read performance, right? But since 2.7, we supported two other mechanisms to compact their data in Iceberg. One is small file compaction, and the other one is called files with delete compaction. So what's the difference between these two different types of compaction strategies? So for small file compaction, it means that okay, you can set let's say a file size, let's say 1 megabyte, right? As long as the file is smaller than 1 megabyte, we will compact the data periodically. Let's say every 1 minute or every 10 minutes, right? We can do that. So basically for this compaction strategy, we focus on compacting the files that is smaller than a certain size. We will merge all this for every single, let's say, 1 minute or every single 10 minutes. We will scan our tables and identify all the files that is smaller than, let's say, 1 megabyte, and then rewrite them to merge them into a bigger chunk, a bigger file, and store them back. That's the strategy. And for files with delete compaction, it's much easier to understand. It's different from the file compactions. For files with delete compaction, it means that okay, as long as we find that okay, it's a new file and it has some deletes, right? And we will just compact them into a larger file. Because for the key challenge in the compaction is how to handle the delete and update, right? So for updates, well, it can be treated as an insert and delete, right? So as long as for the files with delete compaction, we will basically identify the delta and compact all the delta files into a larger file. So yeah, so again, with 2.7, we will support for full compaction, small file compaction, as well as file with delete compaction. So how to use this strategy, how to use them? So again, well, I mean, just want to set a simple, very simple, a very simple parameter. That is, well, whenever you create a, let's say, here I just use the create sync statement, but well, I mean, it also you can use the same parameters in some other statements like create a connection. So you can set a compaction type to small files, and then here you can see that okay, the small file you can set the small file threshold here, as long as the file is smaller than 128, it will be compacted, and the compaction interval here is set to it's 1,800 seconds, right? So this is how we set. Similarly, if you want to do, let's say, use this strategy, you can basically set a compaction type into files with delete, and then you can do the same thing and set a threshold. Here you probably don't really need to set a threshold. So that's how we compact the data in RisingWave since 2.7. Again, I mean, we do have already supported full compaction, small file compactions, and files with delete compaction. So another very interesting features we have introduced in 2.7 that, okay, I found that, but there's yeah. So another very interesting features we were supporting 2.7 is refreshable Iceberg tables. What does refreshable Iceberg tables means? Imagine that we want to ingest the Iceberg tables for data the data from Iceberg into RisingWave, right? Probably you want to serve the data using RisingWave. And in the past, RisingWave does support ingesting data from Iceberg as long as the Iceberg table has the append-only data. right? Let's say that we just append the data into Iceberg. RisingWave can always ingest the data from Iceberg. But what if Iceberg has delete and update? In the past, RisingWave didn't really support that because, well, I mean, that could incur a lot of like internal works. But well, I mean, from 2.7, we have already supported ingesting data from Iceberg, even if delete and update happens. So, how it works. So basically, it works like, okay, RisingWave will periodically talk to check with the Iceberg catalog table, and we will track, okay, which file get updated. And whenever we notify that, okay, there are some updates, we will basically fetch the data from the tables, from the files, and then basically to ingest the data, ingest the data, the delete and update from the Iceberg table into RisingWave. So for this, in order to use this, the only thing you need to do is to set the refresh mode to full load. So basically, for once you set a refresh mode to full mode, it will enforce the RisingWave to periodically load the data from Iceberg, even if it had a delete and update. And you could also set a refresh interval to let's say here I set to 60 seconds, right? Which means that okay, so the table will be refreshed every 60 seconds. So, I mean the Raging will basically fetch the data from Iceberg every 60 seconds. So that's why we can ensure that the table is always up to date. I mean, if you do have some strict requirements of the data freshness, you could definitely reduce the fresh intervals from let's say 60 seconds to let's say 30 seconds. But I think typically in most cases in most cases well in our customers use cases we find that 60 seconds could be reasonable. Yeah, for many applications. Okay, that's the Iceberg integrations. So we have already gone over the vendor credentials. We have already talked about the compaction as well as the refreshable ta Iceberg tables. As you can see, ResonWave could be one of the best solutions in the world in supporting either loading data from Iceberg or writing data into Iceberg. So after talk about Iceberg, let's talk about backfilling performance optimizations. As I mentioned, the one of the key challenges in stream processing system is how do you create a material queue, right? I mean, definitely, whenever we talk about raw material queues and whenever we talk about stream ingestion, we could think about, okay, it's like, okay, continuously ingest the data from the upstream sources, like either the external system or internal tables or internal material queues, right? I can directly ingest the data and then do the computation and then and update the material queue, right? But the pain point, as I mentioned previously, was that okay, basically, if your upstream tables or upstream material queues was big, let's say 1 TB or 10 terabytes, it could take hours into creating the material queues, just bootstrapping the material queues, right? Because we actually have to scan the entire table, upstream tables, and then create a new table, right? It's very, very time consuming. And we have to, and it's also heavily depends on the complexity of your pipelines, right? The complexity of the material logic, right? Imagine that we have if it's just a scan, I mean, I think it could be like a very simple, but let's say that's where your material queue has something like joins, aggregations, group by, right? So it could probably take a much longer time, right? So in 2.7, we introduced two solutions to help you to accelerate through the query material queue creation. One is called intelligent index selection, and the second one is called locality backfills. These two mechanisms are kind of like related, and I will also discuss what the similarities of these two mechanisms. Let's talk about intelligent index selection first. So first of all, I have to admit that okay, I generate diagrams using Google's Gemini for Nano Banana. I feel that is definitely very amazing product for, and I really like that. And I mean, you can see that okay, it just generated a very beautiful diagram for me. So, but anyways, well, I mean, the key challenge of the backfilling is that what is in index selection? So basically, it means that okay, during the backfill, the optimizer, RisingWave's optimizer, will automatically help you to pick the best index and reading the key order by join and group key to improve the cache locality. So what does it mean? Imagine that when in RisingWave you want to create a matrix view, right? I don't know, well, call it, let's say matrix view 1, right? And imagine that when the matrix view was dependent on an upstream matrix view called matrix view 0, right? And in matrix view 0, it has three columns, A, B, and C. And now for matrix view, for matrix view 1, the new matrix view, you want to group by the statement is like, okay, select something, right? And group by C. So, and for the if your source table has the primary key equal to A, have the column A as the primary key, but have an index in column B as well as the index column C. But RisingWave was decide, okay, which primary key, oh, sorry, which index it will use to backfill the data. Without this strategy, how RisingWave will do? RisingWave will do, what RisingWave will do is like it will directly scan the base table, which is wrapped by the primary key, right? Basically, it will scan the primary key. But if you scan a table by the primary key, the challenge here that, well, since we want to group by C, right, we will actually have a lot of random access because essentially, what we want to access is not A. What do we want to access? What the value is actually in column C, right? So if we scan using the pKa, it means that okay, we will have a lot of random access from the disk, right? And this is really very time consuming because we know that for backfeeding, most of the bottleneck is essentially the I/O bottleneck, right? Well, it's not a compilation bottleneck, but it's the I/O bottleneck. I/O is always more expensive compared to the compaction, right? Sorry, IO is always more expensive compared to the computation, right? So without for the index selection strategy, it will be definitely very expensive to select the data from to scan to backfill the data from the upstream tables. So, but with the intelligent index selection, what the writing will do is that okay, it will check okay which table has what kind of index we do have in upstream tables, right? Here it then identifies that okay we do have the table we do have the um yeah, we do have the index on column C, and we want to index. We also want to group by column C, right? So it will pick this index and scan the data directly using this index. For the index C, if we have the index C, you know that okay, all the data is actually sorted by C, right? So we can just scan the index and fetch all the values in C, right? So in this way, it will definitely eliminate almost all the random IOs, right? But that's why it's just a screenshot read. And it can remove all the random IOs and the scale and perform the basically the sequential IO directly. And it will end up with a very fast backfilling performance. And in production workloads, we have already seen the great improvement of this strategy. And in some extreme cases, could definitely lead to, let's say, 10x improvement in the backfilling performance. So that's the intelligent index selection strategies we have introduced in point 2.7 in RisingWave. And then let's talk about for the locality backfill. For locality backfill, it's kind of like similar to it's actually kind of like relevant to intelligent index selection, but well, it's still kind of like different. So what locality backfill means? Locality backfill means that okay, it will basically reload the data or backfill the data based on the locality. Imagine that, well, okay, I can just describe it in a very short word. Well, I mean, imagine that you want to backfill the table. If you want to, if you want to backfill material U, right? And this material U is depend on the base table. What if there's no such kind of index called index C, right? Well, let's say that we want to group by C. What if there's no kind of such kind of index, well, on table C? Then, if we do not really have the index on table C, we actually have to, as I mentioned, we'll just scan by the primary key, right? We'll scan the entire table, which is ranked by the primary key. It could be very slow. So the strategy for locality backfill, what it means that well, it will automatically create the index on the column C because what we found that way it doesn't really exist, right? So we will automatically create an index on column C, build the index, and do the backfill, and drop the index. So everything is automatically. You do not need to worry about, okay, whether I can see the index. No, you will not see the index because we're RisingWave essentially create a matrix you automatically for you. And after that, after creation, it will drop the matrix you. So here I can demonstrate, well, I mean, I can use this diagram to explain how it works. So for the so as I mentioned, well, imagine that we want to ingest a table, or if we want to backfill the data from the table A, right? Oh, sorry, from the source table, right? And for the source table, it has a primary key A, right? And if we just use and if we just use this primary key to scan the data, we will end up with a lot of like a random access, right? So what we'll do is that we will essentially build a temporary state table, which could be like considered as an index, right? Well, and this index, well, and the key prefix is C, which means that's why it's essentially kind of like index on the table on the column C, right? And after building the index, we will do the sequential backfill, as we just have already discussed in the previous slide, which is basically to help you to eliminate all the random access, right? And after creating the matrix U, we will drop out the temporary table, which is this table. We will drop this. We will purge out this table. So people may ask that, okay, whether it will could be take a very long time to create such kind of index. Because well, in the previous slides, we have already mentioned that well, the index on table column C was actually created by you, right? Or created by human. It was already there. But if it was not there, we actually created this kind of temporary index or temporary state table, right? Um, so whether it will take a very long time to create such kind of table. So I can tell you that, so don't worry about that. So creating such kind of index is very fast in RisingWave because, well, essentially it's kind of like a sequential scan by the column A, right? Well, guess what? It's just a building index. And the RisingWave supports a parallel building of the index. It can use multiple threads to build the index. So for building the index is very fast and there's no computation involved, right? But it's basically a scan. So there's no computation involved. So for this, well, with this strategy, you can see that well, because of the building the index, the cost of the building index is so cheap, we can definitely leverage. We can definitely spend some time building index and then do the backfill. And after that, we push out for the temporary table, so that's why it will not occupy a lot of spaces, right, in your system. Yeah. So that's the locality backfill. For locality backfill, I mean, it's as I mentioned again, well, I mean, it's a kind of like advanced feature. Sorry, advanced feature as well on top of the index selection. Okay, and okay, that's the backfill, right? So we supported, well, as I mentioned, we have already supported index selection and the locality backfill. And then let's talk about the securities. It could be like a boring feature, like if you do not really do the on-prem deployment. But I have to say that for a lot of like enterprise customers, like banks, like trading firms, like brokerages, they do care a lot about the security, and they do have the LDAP, right? Specifications for adopted in-house, right? For the RisingWave has already has supported LDAP and has already adopted by some of the by one of the some of the world's largest enterprise customers. And for LDAP, well, I mean the key highlight I want to, I mean it's just basically implementation, but what I definitely want to highlight that well, it's compatible with Postgres LDAP authentication mechanism. And we support both the simple bind and the search and bind. And you can easily enable it via the HBA config. We support both the LDAPs and all the TLS. Well, I mean, because well, this is the advanced feature for just for enterprise customers, I will not spend a huge amount of time in discussing how you want how you want to use that. Well, because well, I mean, if you do not really know that, we probably don't really need that. If you know that, if you really need LDAP, then you know how to use that, right? So I'll definitely skip this topic. Okay. And after that, and that's what we have already introduced in RisingWave 2.7. That in to yeah as I discussed, well, it will include the Iceberg integration, better Iceberg integration, better backfills, and enhance the securities. Then let's talk about spend some time talk about the RisingWave's 2026 roadmap. We definitely want to do have already planned a lot of things for 2026. And I have to say that we didn't really have the documentation or blogs published yet because for a lot of features are still under discussion. And you know that okay, I mean the world is changing so dynamic, right? Well, the iceberg even in iceberg world we have the V3, right? Well, and for the broader world, we have some people are talking about AI, and people asking us a lot about the AI questions like the how whether we want to support something like embeddings, trunkings, whatever, right? We have a lot of things to under discussion, but I definitely want to share with you some of the things we have some of the things we have already had in mind. That is what the source connectors enhance the workload isolation and enhance the OLAP processing and as well as the Iceberg integration. And lastly, I want to talk about the agentic AI. Um, okay, so there's a one question. Okay, there's one question regarding the backfill. So I just want to answer that question first. For backfill, why not just the question is that well, for backfill, why not just sequentially read by the primary key A and hash dispatch rows to downstream MV group by C? Then we don't need to worry about the indexes and temporary sort. Yeah, well, actually, I mean, before 2.7, we do use a strategy. We do use strategy. So basically, we read a PK, right? Well, we read the primary key A, and then we hash dispatch the rows to down by C, right? But the thing here that well, what's the problem here? The problem here is the random access, right? So the why is the random access? Because the table is sorted by pKa, but the value we want to access is C. It's not A. It's C. So so here, I mean, just like for this diagram, you can see that well, probably A is co-located with C, but well, essentially in the real world, it's not a case, right? Well, let's say that where you have 100 columns, right? And A is on the one side, and you are accessing, what the value you want to access is probably column Z, right? So I mean, it will have a lot of like random access because for column A, it's not well, you cannot read both column A and column C in the same cache line, right? So that's why the cache locality is not very good, and you can imagine that it could be very slow to access that. But if you have already had a col have already had an index on column C, it'll be like just a sequential access, right? Because well, I mean, all the column on the column C, all the values on C is well in the index, is stored in the index. So that's why it's just a sequential access, and there is no cache miss, right? So that's a difference. Yeah, before 2.7, we do use the strategy describes well that is basically scanned by A and then dispatch the C to different groups. But you can see that okay, with the index, right, they will definitely have a much better locality, right? That's the tricks we played. Okay. Yeah, hope that's wrong answers question. Okay, yeah, let's talk about what the Iceberg RisingWave 2. 2026 roadmap. So yeah, the first thing we want to support is the more source connectors, especially the HTTP and WebSocket. Oh, sorry, webhook. So people ask a lot about okay whether we support for the ingesting data from some apps such as Salesforce, such as HubSpot, such as well I don't know. I mean, yeah, Notion, Slack, yeah, wherever, right? Well, there are a lot of like apps. So one thing I want to mention is that we're not like a five trend, right? So we're not like yeah, we're not like just data integration services. We are basically a database. So we are probably will not will implement every single data source will yeah inside of a Redmi kernel, right? But people do have the need to ingest data from different sources. Then how we can support that? So for RisingWave 2026, we are trying to introduce the new strategy that a new strategy that called about RisingWave plugin. For RisingWave plugin, it will leverage the RisingWaves for the UDF mechanism. So you do not need to understand the details well when you use that. But well, I was just talk about what the under the hood, what we implement that we're using RisingWave UDF. So basically with the UDF, it can talk to different, well, directly talk to the different services like Salesforce, like HubSpot, via their HTTP endpoint, right? Because for all the different SaaS services, they have an HTTP endpoint. We will definitely directly use the HTTP endpoint, our UDF service to talk to their HTTP endpoint, so as to fetch data from the different apps. And it will be introduced as a revenue plugin services. So that's why with that service, well, I mean, you can directly ingest data from various kind of like different sources. Okay, back to the question. So is the PKA random IO caused by the underlying key value store? Yes, yes, yeah, that's right. Yeah. So basically, it's the yeah, it's so yeah, it's a key value storage, right? Well, let's imagine that. Well, as I mentioned, well, if you have 100 columns, well, it's a because well, it's a key value storage, right? So column A and column Z could be like yeah, could be located in different addresses, right? Well, and they are not in the same cache line, so that's why. Yeah. Um. Yeah. So yeah, as I mentioned, well, back to this topic, RisingWave introduced RisingWave introduced the RisingWave plugin services. So that's where you can directly use RisingWave plugin to talk to different service, ingest the data from different SaaS services. And for stream processing, we definitely want to further enhance the our capacities for for processing streaming data. And the mechanism we want to, so the focus we want to have, we have is not is on the workload isolation and and some optimizations. For workload isolation, we have already supported workload isolation, but we are trying to introduce some even more advanced workload isolation. So that's for different jobs or different streaming jobs will never be aware of each other. And they can have different schedule yeah different refresh frequency. So for example, for one materialized view, it could be refreshed or every time a new event comes in. But for some other materialized views, it could be like refreshed every single minute or every 10 minutes. we will support this kind of mechanism to ensure that well, you have a better workload isolation. Because well, in streaming jobs, well, I mean, in streaming world, some of our customers may have hundreds of the threads used, and not all of the threads you need to be refreshed every single second, right? And some of the threads you could be just like refreshed every, let's say, 10 minutes or even an hour. And we will support that in 2.7, sorry, not 2.7, but well, I mean in 2026. And for optimization, we will also do a lot of optimizations like TTL, like some other optimizations to ensure that we can have you can have the best cost efficiency for processing streaming data. And for OLAP processing, people talk a lot about OLAP processing in RisingWave these days. Well, because well, yeah, after so basically the thing here that okay, people yeah after syncing data into Iceberg, people probably just use RisingWave to directly fetch query data instead of using a third-party query engine, right? RisingWave does support that. Well, we'll support that in 2026, and we have already had done the internal experimentations. So basically, the mechanism we will use is that we are using Data Fusion Query Engine to directly query data. Data Fusion is definitely very popular and very powerful query engines in the world, and we have already integrated with that in RisingWave. And from February, probably even probably later this month, we will push that feature to some of our customers and to basically to test the performance, to test the stability as well as the performance. And if everything goes well, then probably we'll release that in February. And we have already worked on this feature for probably 2 or 3 months. Yeah, it's definitely very interesting features, and I hope that's way that we help a lot of customers to query data from yeah to directly perform analytics in RisingWave. For enhanced Iceberg integration, we'll be pretty much focused on V3 support because we know that for just a few months back, probably just 3 months back, well, V3 was officially released, right? And there was, yeah, everyone just trying to catch up, right? And we are definitely one of the leading solutions for supporting V3 and we are currently working on that. And for I think for the by the end of this quarter, probably February, we will have the delete vector, delete vector support. Yeah, so we will definitely spend a huge amount of time in supporting the Iceberg in Iceberg. And the people ask a lot about agentic AI, right? We also focus on that part. We are basically focused on two things for these days. One is that we're supporting directly calling models, what are area models or embedding models, right? So how we do that? Well, it will be also imported included in the RisingWave plugin feature as I mentioned in the source connectors. Because well, for using with RisingWave UDF, which you don't really need to understand for the data interpretation, but with RisingWave UDF, we actually can directly talk to HTTP or external services. So we can use this strategy to directly talk to LLM models or embedding services. So that's why in 2026, you will be able to. I mean, these days we can have already done that, but I mean, in 2026 we will support an even more flexible mechanism to help you to call the LLM inside of RisingWave and so as to do something like embeddings or summarizing text or probably generating something, right? Or to do the enrichment. So as again, I mean these days, well, could already do that inside of RisingWave, but in 2026 we will support a more flexible way to do that. And the other very interesting topic we want to discuss is that okay, the proactive agent. We actually have already seen this. Well, I mean, people using RisingWave to support um their I mean agents, right? Proactive agents inside of their environments. So the idea here is that well, for RisingWave, it can continuously ingest the data And for some agents, for in enterprises, well, they actually want to monitor the real-time data, right? Well, they probably have some telemetry data, or they probably have some, let's say, uh, yeah, observability data. I'll probably have some, let's say, the yeah, a lot of like sensor data, right? They have a lot of this data, and they want to monitor the data. They want to monitor the data, and once they feel that okay, there are some anomalies, they probably want to trigger the agent, and the agent can do the analytics, right? This is a pretty common use case. But what I'm trying to mention is that you should not call the LLMs every time a new event comes in, right? It's not kind of realistic. So what we're doing right away is that we're collaborating with some of our already collaborating and with some of our customers. What we do in Writing Wave is that we actually help you to pre-process the data, right? We actually help you to figure out, well, okay, which could be the anomaly, right? And in the past, what people does was that, okay, they just write a SQL, right? Well, they set a threshold. Let's say that if the CPU utilization rate is larger than, let's say, 90%, send me a notification, right? And then I can trigger I can spawn an agent to do the analytics, right? That was in that could have already achieved inside of today's Rising Wave. But in 2026, we are trying to introduce some ways to help you to set a threshold. So that's why you don't really need to do that on your own. Because well, for humans, well, it's always different, very different, difficult to understand. Okay, when yeah, what a threshold should be set, right? So we're not trying to use LLM, but well, I mean, for setting a threshold, we're probably not trying to use LLM because well, there are some smaller models that could be more efficient in analyzing the time series data. And we will also introduce that for inside the writing wave, so that okay, it will help you to better set a threshold and better set the identify the anomalies inside the writing inside your time series data, so as to trigger the proactive agent wisely, right? And that's definitely something we are currently working on. Well, all right. So I think we have already spent a huge amount, a lot of time, almost an hour discussing the Rising Wave, yeah, 2.7, as well as the Rising Waves 2026 roadmap. And we will deliver, as mentioned, for Rising Wave 3.0. And I hope it will be in the first quarter. It will be likely to be in the first quarter, so within 2 months, because it take us to do a lot of testings or to do a lot of planning. So, but we are currently working on that. And we will also release some blogs regarding the preview of 2.7. So, sorry, not to 2.7, 3.0. So if you're interested in that, well, definitely let us know. And you're more than welcome to join our committee. All right, thanks, everyone. If you have any questions, feel free to ask in the channel. And yeah, that's it for today's webinar. Thanks.